Lesson 13-6 is surface area of pyramids. So the first thing we want to do is we want to watch the video in Khan. It's called Surface Area Word Problem Example. Once you watch that video, then make sure your homework is written in your planner, and we want to finish, we want to write this vocabulary. So, a pyramid is a three-dimensional figure that has one polygonal base and triangular sides that meet at a point. Okay, so if you look at the diagram down here, polygonal, that just means polygon. It's a polygon. Okay, so here, the base of those two, those are squares. That's a square. This polygon is a rectangle. So it has a polygonal base. That's how you say that. Polygonal base, and it has triangular sides. Now the sides of the pyramid are called lateral faces. So going back to our picture, the sides are called lateral faces. So here's a lateral face. This is a lateral face, lateral face. Those are all the sides of the pyramid, the triangular sides. Those are called lateral faces. The height of one of the lateral faces in a regular pyramid is called the slant height of the pyramid. Now let's go back to our pictures, and we're looking at the slant height. Now the slant height, okay, I'm going to do this in pink. The slant height is the height of a lateral face. You see how it drops down to a right angle there? See how it drops down? This is the slant height. Over here, if you're looking at the neck, this is the slant height. Okay, you see all that? The slant height of each of those lateral faces, that's the slant height. So if I'm looking at this picture, the slant height is right here, right there. And that drops down to a right angle, right there. Now, you'll notice that there's another height in here, okay? This height right here is not the slant height. This is the actual height of the pyramid, okay? So here we've got, this one is a slant height. And this one in here, let's do that in green, this one right here is the height of the pyramid, of the whole pyramid. Okay, and they are different. If you look at it, if you measure them, you will see that the slant height is going to be a tad longer than the height of the pyramid. So you need to make sure you do not get those confused. So the slant height is the one on the lateral face. Okay? All right. A square pyramid is a pyramid with a square base and 4 triangular faces. So remember, the base is a square. A right rectangular pyramid is a pyramid with a rectangular base and 4 triangular faces. Okay, so if we look back at our picture here, okay, see, this is an 8 by 8. This is a square, so this is a square triangle. If you look at this picture, okay, I'm just going to mark them. These, all 4 sides, are congruent. So that is a square pyramid. That is a square pyramid. And then over here on this side, you can see this side is congruent to that side, and this one is congruent to the opposite side over there. So this is a rectangle base. This is a rectangular base, so this is a right rectangular pyramid. Right rectangular pyramid. And I don't know why they call it a right rectangular pyramid, because all rectangles have all right angles in each of their corners there. So I don't know why they call it a right rectangular pyramid, but that's what they call it. So it's called I would have just said rectangular pyramid. But this is a right rectangular pyramid. Oh well. All right, so example 1A is to make a net to represent the square pyramid. So we want to draw and label a net to represent this square pyramid, and we want to let each grid unit represent 1 centimeter. So when you look at the picture, first thing you want to do is say, what are my shapes, right? So here you can see this is a 4 by 4. So all of the sides are congruent. So this is a 4 by 4 square, okay? You can also see that the height, the slant height, right here, the slant height is 7.23 centimeters, okay? So that's what we want to take into consideration. Now, when we're putting it on the grid, well, we know that 0.23, if we're, we can say this is close to 0.25, which is 1/4, right? So we know how to estimate close to 1/4, okay? So that's what we're going to do when we draw our figure. So the first thing we want to do is we want to draw a 4 by 4 square. So here is our 4 by 4 square, okay? And I'm going to label in here that this is 4 centimeters by 4 centimeters, okay? So now we want a triangle that goes 7.23. So that's 1, 2, 3, 4, 5, 6, 7, and then a little bit more right about there. All right, so here that's 1, 2, 3, 4, 5, 6, 7, and then a little bit more right up to there. So here is one of my lateral faces. So let's label this. Okay, so this we know is 4, and we know that this slant height, as a matter of fact, let me do that in green. The slant height, this green right here, this is 7.23 centimeters, okay? Now, we know because it's a square pyramid, we know that each one of the triangles that's going to be on this side and on this side and on this side is going to be all the same as this one, okay? So let me get that on the video, on the drawing. So there is the rest of the net. So we know that the slant height is 7.23 centimeters. The base is a square. It's a 4 by 4. And that's it. So here is example 1B that you should do on your own, and then you can restart the video to check it out. So, sorry, I had to fix the directions. So here we want to draw and label a net to represent this pyramid, and we want to let each grid unit represent 1 foot. All right. So go ahead and pause the video and do this one on your own, and then start it again to check it. So the first thing I want to do is I want to check my measures. So here this is a 4.8, this is a 3.8, the slant height is a 2.9, of course 2.9, I'm going to write it up here, I'll put this 2.9 here. 2.9 is almost, of course, 3. Almost 3 feet. Okay, so we know that what we need to do to estimate. So let's start with the base. So the base is a 4.8 feet. So that is almost 5 feet, a little bit less than 5 feet by 5 feet. Okay? All right, so my square is a 4.8 by 4.8. Now, that 4.8 is the base of the triangle, and the triangle, the height of that triangle, so that means the slant height, that's this one right here, you guys. This is the slant height. to a right angle, that slant height is 2.9. Okay, the slant height is 2.9. So this is what your pyramid looks like. Now, was there some information here that we did not really need? Oh, yes, there was. This right here, they were telling us the side lengths right here. They're saying that this was 3.8 feet and this was 3.8 feet. So, did we really need this information right here? Nope, did not. We only need the base and the slant height to draw the net. There you go. Example 2a is to find the surface area of the square pyramid. So we're going to use this net to find that surface area. Alright, so when we do the surface area of a pyramid, especially if it's a square pyramid, we know that we have a square and we know that we have 4 triangles that are exactly the same. They are congruent triangles. So, we can write our formula. We can say surface area is equal to the pyramid, or let's call it the base, plus the 4 lateral faces. So 4 lateral faces. Okay? So the base is a square. So the formula for that is base times height. Base times height. Plus the area of the triangle is 1/2 base times height, and we have 4 of them. So we can multiply that times 4. So here's the formula that we're going to use to substitute in. Okay? So the base is base times height, that's 5 times 5. Then we're going to add the 4 lateral faces. Now, we have 4 of them, so that's times 1/2 times the base of this triangle, which is 5, and the height, or the lateral height of that this pyramid, so the height of the triangle, or the lateral height of the pyramid. So that's going to be 4.3. So times 4.3. So 1/2 base times height. So this is my substitution. So now I can simplify. So 5 times 5, of course, is 25. Over here, we can simplify before we multiply. We see 2 divided by 2 is 1. 4 divided by 2 is 2. And now we have 2. This is times 1, so that cancels out. So 2 times 5, that's 10. And then 10 times 4.3 is 43. And now when we add that all together, we've got 68. And this is going to be in a surface area, so this is centimeters squared. And that's all there is to it. So for example 2b, go ahead and press pause on the video and go ahead and find the area of example 2b. Alright, so here is example 2b. So we have the base plus the 4 lateral height, the lateral faces. So that's base times height, and the triangles, 1/2 base times height. So here's my substitution. And then when we simplify, we ended up with 99.84. Please remember, you can simplify before you multiply. So I simplified the 2 and the 4 here, and then I have 2 times 8, 16, and then 16 times 4.8. That's what gave me this 76.8. Alright, so for this example, we're going to find the surface area of a right rectangular pyramid. So it says a container shaped like a right rectangular pyramid has the dimensions shown. use the net to find the surface area of the container. Okay. So I want to let you know that even if you don't have the net, you can see that this is a rectangle, okay? You can see this is a rectangle because this is a 5 by 3. So those are not all congruent sides. You know that's a rectangle. You also can find your lateral height, okay? So lateral height for this side is 6 meters, and lateral height for this side is 4 meters. So you don't need a net to see all of these, okay? Now when we have a rectangle, you'll also need to notice that of course we have a rectangular base, that's the base, and we've got this triangle and this triangle. Opposite triangles are congruent because they have the same base. And then we've got this triangle and this triangle are also congruent. So what we're going to do is we're going to find one of them and multiply times 2. And same with this one, the yellow triangles, we're going to find this one and multiply times 2. Okay? So let's start with writing down what we're going to use to get our surface area. So we want the base, okay? We want the base, and then we've got the, then we've got 2, we're going to add 2 of the triangles, okay? So 2 of the faces, and let's call that with base 5, okay? And then plus 2 of the faces with base 3. Base 3. Okay? That's how you can keep them straight. Alright? So now we've got, again, you know base of the rectangle. That's good. The area of the rectangle is base times height. And so this is going to be, each of these faces is going to be 1/2 base times height. So that's 2 times 1/2 base times height, and that's for the, yeah, write that nicer. So that's going to be 2 times the triangle with the base of a 5 plus 2 times 1/2 base times height, and this one is going to be a triangle with a base of 3. You got to make sure you keep them straight. It looks the same here, but you need to make sure you keep it straight and what you're substituting. Okay, so we've got base times height, so that's going to be 3 times 5 for the rectangular base. So 3 times 5 plus 2 times 1/2 times the base of the triangle with the base of 5. So that's 5 times the height, which is 6. And now we're looking at the triangle, the yellow triangle. So that's going to be 2 times 1/2 times the base of 3 times the height. The slant height here for that triangle, or the height of that triangle, is 4. Okay? And now we can simplify. So here, 3 times 5 is 15, plus, all right, so here I just highlighted them so you can see what goes with which one, okay? So again, you can simplify before you multiply. So I'm going to go ahead and simplify the 2 and the 6. So 2 divided by 2 is 1, 6 divided by 2 is 3. So now we have 2 times 1 times 5 times 3. So 2 times 5 is 10 times 3 is 30. Plus, and then over here, again, we can simplify before we multiply. So I am going to simplify the 2 and the 4. 2 divided by, actually I can do the 2 and the 2. And then 2 divided by 2, 1. So that's going to be 1 times 1, which is 1, times 3 times 4. So this is just 3 times 4, which is 12. So when we add these together, we've got 15 plus 30, that's that's 45 plus 12. That gives us 57. So that's going to be 57 meters squared. Okay? So it helps, again, it helps to write what you're going to add together and then substitute with your formula and then substitute with the actual numbers. Okay? So I would like for you to do example 4A. Well, let's go ahead and do this one together. So it says Omar has a garden for vegetables that measures 4 feet by 4 feet. So you know that's a square pyramid. He placed a pyramid-shaped net over it to keep the rabbits out. The bottom of the pyramid is not included because, of course, that's where the garden is, right? The netting costs $1.40 per square foot, and the framework, that's the wood up here, the total cost for that was $12. So we want to know how much did Omar spend to build the net. So we want to find the area of the net, and we also want to add how much it costs for the support beams here, which is the $12. Okay, so let's start by finding the area and the cost of that net. So remember, it says that the bottom of the pyramid is not included, so we only want to find the surface area of the 4 lateral faces. And because this is a square, we can just find one of them and multiply times 4. So this is going to be 4 times 1/2 base times height. So for the base, let's just mark it. The base is 4 feet. And the height of this triangle, or the slant height, is 3.5. So that's what we're going to substitute into our formula. So we have 4 times 1/2 times the base, which is 4, times the slant height, or the height of the triangle, which is 3.5. And now we can simplify. Okay? So, let's simplify. 2 divided by 2 is 1. 4 divided by 2 is 2. And then you have 2 times 4. 2 times 4 is 8. And now we're multiplying that times 3.5. So we've got 3.5 times 8, and that gives us 28. So this is going to be 28 feet squared. Okay? Now, we want to find the total cost. So that's going to be the cost of the net plus the cost of the support. Okay, so first, what do I have to do with this 28 feet? Well, it says that the netting costs $1.40 per square foot. So that means down here, we need to multiply this times $1.40. And that's going to give us the cost of the net. So we've got the 28. We're going to multiply that times $1.40. And that's going to give us $39.20. Don't forget, you got to put a 0 over here, okay? So this is going to be $39.20. That's how much it costs for the net. Plus the support, it says here that the support costs $12. We didn't have to calculate anything for that. They just told us it's $12. So now you just add from to the $39.20 plus $12, and that gives you $51.20. $51.20. So this is the amount, $51.20. This is the amount that he's going to pay to build that net tent. So for example 4B, I would like for you to pause the video and do this one on your own. Okay? It says, Lynn is constructing 3 different square pyramids for a classroom display about Egypt. The dimensions of the pyramids are shown in the table. How much more surface area does the pyramid with the greatest surface area have than the pyramid with the least surface area? So, to figure this out, we want to find the surface area of each of those pyramids, and then if I want, because it says how much more, we're going to subtract. How much more surface area does the pyramid with the greatest surface area have than the least? So we're going to subtract the biggest minus the smallest. Okay? So go ahead and press pause and get that one done. So the first thing we want to do is we want to find the area of each one of these pyramids. So here I've got the surface area is equal to the base plus the 4 lateral faces, and I wrote my formula, I substituted, and I simplified to get my final answer. So pyramid A is 127.5 inches squared. Pyramid B is 120 inches squared. And pyramid C is 180 inches squared. So we want to know how much more is the pyramid with the greatest surface area than the least. So when we look at this, pyramid C has the greatest, and pyramid B has the least. So we are going to subtract pyramid B minus pyramid C. So that is 100. Oh, I'm sorry, I got it backwards. We got subtract pyramid C minus pyramid B. The greatest minus the smallest. So that's 180 minus 120. So that's going to give us 60 inches squared. So the question was, how much more surface area does the greatest pyramid have than the smallest pyramid? And there's our answer. 60 inches squared more. Okay.